Okay, here we go. Shh. The first thing we're going to do is we're going to write down the definition of a geometric sequence. So just write small. I'm going to start it up here. A geometric sequence is a sequence of numbers where each term after the first is found by multiplying each term, or no, sorry, by multiplying the previous one by a number called the common ratio. I'm just going to draw a little arrow right there, common ratio. Okay, so look, a sequence of numbers where each term after the first is found by multiplying the previous one by a number called the common ratio. So with arithmetic sequences, we were adding or subtracting, and the number we were adding or subtracted by was called the common difference, and we labeled it D for common difference. With geometric sequences, you're going to be multiplying by the same number each time, and that's known as the common ratio, so it will be known as R. Like you see on the board that in arithmetic formulas, they use D for common difference. In geometric, it's an R for common ratio. Okay, in the first 6, the directions are to determine if the sequence is geometric first. If it is, find the common ratio. Well, to determine if it's geometric, it has to meet the criteria given in this definition. Is this a sequence of numbers where each number is found by multiplying the previous one by the same number every time? Okay, so it is geometric, and what did you say they're multiplying by every time? -6. Because look, a -1 times a -6 will produce a +6. And then a +6 times a -6 will give you a -36. And then -6 times -6 will give you +216. Okay, so now let's look at number 2. The sequence of numbers they've given you is -1, 1, 4, 8. That is definitely not geometric, because to get from -1 to +1, you would multiply by -1. But then a 1 times a -1 does not give you a 4. So this one's not geometric, which means there is no common ratio. You just write no. No, it's just no. It's not a geometric sequence. Number 3. Okay, Gabe already said it is. So if it is, that means there's a common ratio. And what is it? Are y'all sure about that? It's a no. Right, it's a no. Hey, I'm telling you what he did. He was like, okay, 4 times 4 is 16, but is 16 times 4 36? No. Okay, number 4. Number 4, is this geometric? Okay, well first try to figure out what they're multiplying by every time. -3 times 5 is -15. -15 times 5 is -75. -75 times 5 is -375. So yes, they are multiplying by +5 every time, which means yes, it is geometric. Okay, take about 30 seconds and try 5 and 6. Number 5, is it geometric? Yes. Because what were they multiplying by every time? +2. Shh, guys, you need to be quiet. Number 6, is it geometric? They were multiplying by what? Oops, I don't know why I wrote y equals. Yes. And then the common ratio is Negative 5. All right, for the next set of problems, the directions are, given the explicit formula for a geometric sequence, find the first 5 terms and the 8th term. Okay, remember, we just did the explicit formula on the warm-up, but it was for an arithmetic sequence. Okay, look over at the whiteboard. Everybody look at the whiteboard. The whiteboard. Okay, see how under arithmetic, the first formula has an E beside it for explicit? Isn't that the formula we just did with the warm-up? Because it was a list of numbers where we were adding by 9 every time, right? Now look at the explicit formula under geometric. Doesn't it look totally different? For geometric, the explicit formula is A sub n equals A sub 1, which you all know is what? The first term, times R, which we just learned is the common ratio, raised to the n minus 1. So to write the explicit formula, well, for this one, they've given you the explicit formula. So what is in the A sub 1 place? Look at it again. Think about what I taught you before the break about a 1. Look, R is 3, because isn't the 3 raised to the n minus 1 and your ratio is always raised to the n minus 1? Since nothing is visible in the A sub 1 place, it's an understood 1. Just like before the break, when we were doing the graphs of exponential functions, if nothing was visible in the A place, then it was a 1, right? Okay, now, to find the A sub 2, any ideas what we do? Okay, well, what's the R of this problem? The common ratio. Okay, and what does the common ratio tell you to do at each time? Right, so 1 times 3 is 3. And then to find the next term, you multiply by 3 again and you get A. And to find the next term, you multiply by 3 again and you get A. And to find the 5th term, you multiply by 3 again and get A. 81. Now, they also want you to find the 8th term. So you have 2 choices. After finding the first 5, you could just go ahead and find the 6th term, the 7th term, and the 8th term by continuing to multiply by 3, because that's our R value. Or you could just plug in 8. If we replace the n's with 8 for 8th term, doesn't that become 3 to the 7th power? And what is 3 raised to the 7th power? You're going to need to calculate it. What'd you get? 2,187? Now remember, you could have also gotten that by just multiplying by 3 to find the 6th term, then multiplying by 3 to find the 7th term, and then when you multiply by 3 one more time, you would have gotten that. But what if they asked for something like the 50th term? Are you really going to want to have to keep multiplying? So whatever term they want you to find, you just plug in for the n. Okay, so now let's look at number 8. What is the first term for this one? Correct. In the A sub 1 place of the formula is a 2. That's your first term. What is the common ratio? What do they want you to multiply by? 1/4. So what's 2 times 1/4? Use your calculator if you don't know. 1/2. And then to find the third term, what's 1/2 times 1/4? Because you're taking a fourth of the number every time. 1/8. And then to find the fourth term, you do 1/8 times 1/4, which is 1/32. And then to find the fifth term, you're just doing 1/32 times 1/4, which is, no, 1/128, because 32 times 4 is 128. Now, to find the 8th term, you could find the 6th, then the 7th, or you can also do what? Well, don't forget the 2, though. 2 times 1/4 raised to the 8 minus 1, so just 7th power is what? 1/. You get a number that's scientific notation, right? Okay, let me show you. Okay, so it's 2 times 1/4 raised to the 8 minus 1 power, correct? There is way too much talking going on while I'm trying to teach. That's what you should be typing in to find the 8th term. You just replace the n with 8. Now you hit enter, and you get scientific notation because it's so small. To change it to a fraction, you have a couple of options. You can just go to math and then number 1, or you could have gone to alpha y equals if that's what you prefer and hit number 4. Whichever way will turn it into a fraction, 1 over 8,192. Because think about it, when you go to the 6th term, you're doing 1 over 4 times 1 over 128, which would be 1 over whatever 4 times 128 is, which is 512. Then to get to the 7th term, you're doing 1/4 times 1 over 512, which is 1 over 4 times 512, which is 1 over 2,048. And so now to get to this number, you just multiply that by 4, and you get to that. Which makes sense. 2,000 times 4 is 8,000. 48 times 4 is 192. Because you're taking a quarter of a number. Think about like a pizza. When you eat, like if you have a pizza that has 8 slices and you eat a quarter of that pizza, how many slices have you eaten? 2. Yeah. Okay. Now I want you to quickly try 9 and 10 by yourself. Try 9 and 10. Okay, remember, in this set of problems, they have given you the explicit formula. So this is the explicit formula, and I wrote the explicit formula up here. So the very first number, that negative 2.5, is your first term. I saw that people were trying to find the first term, but you don't have to find it. It's given to you. It's right there at the front of the equation. Negative 2.5 is the first term. The next number is the r, which is called your common ratio, and it's the number you multiply by every time. So to get to the next number, all you have to do is multiply that one by 4. And what is negative 2.5 times 4? And then to get to the next number, you multiply by 4 again, and you'll have a... And then to get to the next number, you multiply by 4 again, and you'll have a... And then multiply by 4 again, and you'll have a... Right? And now at this point, you can no longer just keep multiplying by 4 to find the 8th term unless you literally write out the 6th term, the 7th term, and then the 8th term. To simply find the 8th term, you replace the n with an 8. And then you would just type that in. Negative 2.5 times 4 to the 7th power. You can go ahead and simplify that to 7. And what did you get? Right. Okay, now let me show you something else cool that will be helpful to you. I don't know if you remember, but when we learned about arithmetic sequences, remember a while ago the answer to this was 9n minus 21? Doesn't that look very, very similar to y equals mx plus b? The m is 9, that's your slope, and the y-intercept is negative 21. So arithmetic sequences, when graphed, make a straight line. Geometric sequences, though, are raised to an exponent, which means they're exponential. They're going to make a curve, which is what we were working on before the break. So just watch me do this the first time. I'm going to graph this, okay? Just watch. I'm going to graph number 9. Y equals negative 2.5 times 4 raised to the n minus 1. Okay, see how all I've done is graph what number 9 gives you, the negative 2.5 times the 4 to the n minus 1, but instead of n I use x. Now, I don't really care about what the graph looks like. You can see that when it's graphed, it's an exponential curve. What I care about is what the table looks like. Second table, well, I didn't give it enough time, hold on. Okay, oops. This is very useful information. I would close my mouth and pay attention. That's not important. Wasn't the first term negative 2.5? And what's the second term that we got? And isn't the third term negative 40? And the fourth term is negative 160? And that's why I'm showing you, Amari. And the fifth term is negative 640. And then the eighth term was negative 40,960. So that's another way you can find the terms you're trying to find. Okay, so now let's use that method to do number 10. First, I'm going to type this in, negative 4 times 3 to the n minus 1. So go to y equals, because we're trying to graph it, and type in negative 4 times your r value of 3 raised to the n minus 1. Okay, go ahead and type it in. Right here, below clear. Okay, once it's typed in, you can graph it. And I mean, we'll see that it's an exponential curve, but we don't really care what the graph looks like right now. We only care about the numbers in the table. So second table. I don't think I did much of that. Okay, now, look, we know the first term is negative 4 because it was given in the formula. The very first number in the formula is your first term. But didn't you, when you did it by yourself, get negative 12 for the second term? What did you multiply the first term by? Okay, bring that over here. Aren't these the numbers that y'all got when you actually multiplied by 3 every time? And so that's another way you could find your answers. So it would have been negative 4 for the first term, which is given. Then you multiply by 3, which would take you to a negative 12, a negative 36, a negative 108, a negative 324, and then for the 8th term, instead of having to plug in 8 at this point, you could just look at it, negative 8,748. Yes, okay, let me see it. Oh, it's because you actually typed in a number. You gotta, when you're graphing it, you gotta put an X for the n. That's why. Okay, now let's look at the next section. Given the recursive formula for a geometric sequence, find the common ratio, the first 5 terms, and the explicit formula. So look, in the previous section, the formula they gave us was the explicit formula. Okay? Now in this section, the formula they're giving us is the recursive formula. Now, the recursive formula is not very complicated. It always looks like this. A sub n equals a sub n minus 1. The only thing different from problem to problem is this number on the end. And that number is the r. So don't you think that since it's times 2 on the end, that means we're going to be multiplying by 2 every time? So if your first term is 2, what's your second term? 4, because you just multiply by 2 every time. So your third term is 8, and your fourth term is 16, and your fifth term is 32. Okay, look. Can you be quiet so I can teach? The recursive formula is not complicated at all. The only difference in each time it's written is this last number, and that is your r, what the number you're multiplying by. This will look the same for every single problem. Okay, this is the only thing that will change, and this is the number that is in the r place, which is the number you multiply by. So once they give you the first term, to find the rest, you just continue multiplying by 2. Now, besides finding out that the r is 2, which you can just find out by looking at, and finding the first 5 terms, they also want us to write the explicit formula. Okay, remember the explicit formula for geometric is a sub n equals the first term times the common ratio to the n minus 1. So for this formula, for this particular problem, what goes first? What goes in the first term spot? 2 times what goes in the r spot? 2, and then to the n minus 1. And now you have the recursive that was given and you created the explicit formula. Okay, so now let's look at number 12. This time they give us the recursive formula and they give us the first term. The recursive formula only gives you one piece of information, and that one piece of information is the what? The R. So they're telling you to do what each time? Multiply by -3 every time. So -3 times -3 is +9. Then +9 times -3 is, and -27 times -3 is, and then 81 times -3 is, okay? And then they also want you to write out the explicit formula. So A sub n equals the first term, which is -3, times the common ratio, which is also a -3, that's just a coincidence though, to the n minus 1 power. Okay, so now let's look at number 13. For number 13, what is the R value? 5. So they want you to multiply by 5 every time. See how the end of the recursive formula is saying multiply by 5? So if your first term is 2, what's your second term? What's your third term? Right? What's your fourth term? And your fifth term? Right. Now to write the explicit formula for this sequence, you just write the explicit formula, which is A sub n equals the first term times the R to the n minus 1. Okay, quickly try 14 by yourself. Find the R, find the first 5 terms, and then write the explicit formula. I don't know. We're already behind second period because there's way more talking in this class. We'll definitely be working till 1 minute till the bell, that's for sure. Like normally I let y'all switch out at like 3 minutes till the bell, but today it's going to be like 1 minute till the bell because we're behind already. Because people can't keep their mouth shut. Okay, for number 14, what is the common ratio? 3. So if the first term's -3, the second term is -9. And the third term is -27. And then the next term is, and the next one is. Okay, so we found the common ratio, we found the first 5 terms. Now the explicit formula would be A sub n equals, right, the first term times the R to the n minus 1. Okay, now turn to page 2. All right, the directions for 15 and 16 say, given the first term, which in this one is that 0.8, and the common ratio, which is -5, they want you to find the first 5 terms and write the explicit formula. Well, they already found the first term, so you have to find the second, the third, the fourth, the fifth, and they also want you to write the explicit formula. Okay, well if the first term's 0.8 and the common ratio is -5, what do you do to find the second term? Multiply that 0.8 by -5 and that gives you a, right? And then you just multiply that by -4 and it gives you what for the third term? That's, well, 0.8 times -5 gives you -4. And then -4 times -5 gives you +20. +20 times -5 gives you -100. And -100 times -5 gives you 500. So we found the first 5 terms. Now we need to write the explicit formula. The explicit formula is A sub n equals what? 0.8 times the R, which is -5 to the n minus 1. And you can write like times, like a dot, or you can write it in parentheses the way I just did. All right, number 16. The first term is 1. The common ratio is 2, so the second term would be what? 2, because 1 times 2 is 2. The third term would be 4. The fourth term would be, and the fifth term would be, right, you just multiply by 2 every time because that's what the R value is. Now to write the explicit formula, what comes first in it? Right. The first term times the R value to the n minus 1. All right, 17 through 20. Given the first term and the common ratio, so just like the last one, this time write the recursive formula and the 3 terms in the sequence after the last one given. Well, for all 4 of them, they gave you the first term. So you're just going to be finding the second, third, and fourth term for each one. How do we find the second term? Right, negative 4 times 6 is negative 24. And then negative 24 times 6 is negative 144. And then negative 144 times 6 is right, negative 864. Now, the recursive formula is different. It's just a sub n equals a sub n minus 1, and then times your r, which would be times 6. That's all you do for recursive. All you have to plug in is the r at the end. So now let's look at number 18. We got to find the second, third, and fourth term. Okay, if the first term is 4 and the common ratio is 6, what's the next term? Spit them out. 24, the third term, and the fourth term. Right. And so the recursive formula is going to be the identical to the previous one because you're just multiplying by 6 again. Okay, for number 19, the first term is 2, the common ratio is 6, so the second term is a 12, and the next term is a 72, because 12 times 6 is 72, and then the fourth term is 432. 72 times 6 is 432. Now the recursive formula would be a sub n equals a sub n minus 1 times 6, because you were multiplying by 6 every time. All right, last problem. A sub 2, a sub 3, a sub 4. What do you have to do every time to get to the next number? So this would be a negative 16, a negative 64, a negative 256, and then your recursive formula would just be a sub n equals a sub n minus 1 times 4. All right, you may switch out.